Well, so that is step one. And then we have a second step. Second step, based on the system, because we need to run simulation, so we need to define the model. And define the model, actually we need to understand the system first. So to understand the system, how to understand the system, we need to collect data, and so that we can be familiar with the system. Once we know the system, then we can define a model for the system. Well, think about this. MM1. Should we define the model? Actually, MM1, before MM1, we may have a system, but we don't call it MM1. Through defining the model, then we can have the model employment, and so that we can have the notation for the system. And then we have, for example here, the MM1 queuing system. So maybe you have a question. Sometimes should we have the data collection and the model definition? The answer is no, because we have the system there. But for the real system, we don't have the model, and so that we need to define the model. And if we want to do so, then we need to have the data collection. Based on the collected data, then we can have the definition for our system to have the model. Well, so this is the real situation. Well, if indeed we need to collect data and define a model, here we should notice the following, maybe some possible items. First one, because we need to study a system, so we need to have the layout. And actually, we need to have the operating procedure. To know all the details, then we can have the system ready for our study. Well, if so, then we have the system. And with the system, then we need to have the corresponding maybe setting configurations. Setting configuration, then based on the setting configuration, then we will have the possible items. Actually, we will have the model. And once we have the model, we will specify the corresponding parameters and to choose the input probability distribution. So, use to specify model parameter. So that says the current procedure, we will choose the model parameter. We will choose the input probability distribution. Well, for this purpose, actually, we will construct the conceptual model. To have the conceptual model, actually, we will have the parameters and the input probability distribution selection. Well, about this, actually, we will define a model. And to define a model, we will specify the input probability distribution and the model parameters. After that one, then we can pass on the model to have the collected performance. And with the collected performance, then we can have some maybe validation. And the validation, then everything is okay, then no problem. But sometimes we will have some further problem. So once we have the collected performance, so the model can be defined here. Maybe not. If maybe not, then we need to have the further details. Further details, then possibly we may have the problem. If we have the problem, who you can contact. because the problem is specified by the manager. So we will contact the manager for the further refinement if we don't think the current system is a realistic system. So we can change something, and so that you need to discuss with the manager. And the manager, maybe we can simply call, oh, your boss. For the manager, you can call it boss. Or for the advisor, you can call him or call her your boss as well. Well, this is second step. For second step, that you have 30 seconds to think about that. Okay, approximately 30 seconds. And because of the online lecture, so I should have some poses. And for the poses, and then we can pose. All right, so we have a few poses, and so that you can think about what I don't know. Or otherwise, you may feel boring, or maybe right now you are dizzy and so that you fall asleep. All right, to avoid that one, maybe this is a different style, and so that I try to that it have possible engagement, and so that don't go to sleep. All right. And next one, we will have the conceptual model valid or not for this checking. If we want to check model value, of course, we need to check by using the program. So we need to perform the structure walkthrough. That says you need to have the program and you need to check for the further details. And then you will know the model value or not. For this one, I think it's simple. That says we need to have the walkthrough based on the structure walkthrough, and then you can check the validity of the model. And next one, we will construct a computer program. And based on the program, same, you need to verify. Verify here, it says debug. So, construct a computer program that says this is the purpose for our course. The purpose for our course, we already have some concept to know how to have the model, and then you need to have a simulation program. How to have the simulation program? Actually, it's the program of a computer program. So we should construct a computer program accordingly, and so that you will know how to have the program for your system. If so, this is step one. I mean, the current sub-step one. Program the model in a programming language. Yes, once you have the program, then do you think everything's okay? Maybe no. If no, then you need to debug. Well, about debug, I think you have your own way, and so that you can avoid bugs in the program. If you can remove it, then congratulations, you are successful in writing the computer program for the simulation. Well, up to now, so you have the correct simulation program. Well, you think, okay, if you have the correct simulation program, then everything's done? No, you need to have a pilot run for initial investigation. pilot here. Pilot run, then it says maybe some tests before the formal experiment or simulation. So that's why before we go formally, so we need to have the pilot runs. Pilot run for validation purposes or maybe for some preparation.